All right, so I've left our original nucleic acid monomer up there, and I've changed nitrogen containing base to A, and the reason for that is that this is the base that is typically used for energy. So it ends up that these phosphates, they're all charged, and if you add an extra phosphate, it takes energy to force it on there. And then if you add even a third phosphate, it even takes more energy to add it in. And the fact that you can force this energy on there, and then allow it to move to another location in the cell, and then release the phosphate and release this energy, this is how the cell moves energy around. So it starts out, it's an RNA nucleotide of adenosine. And if to use the terminology, the shorthand terminology, it would be adenosine monophosphate, but it would be what we would call AMP, M for mono. Now, if we add a second phosphate to that, it adds just a little bit of energy, but not really enough to be useful. It would be adenosine diphosphate. Okay, this is where the good part comes in. You put a third phosphate on there. To put a third phosphate on there, it becomes adenosine triphosphate, and this carries enough energy to be useful within the cell. And so if you look at your notes, you see that ATP is the energy currency of living systems. And it's composed, I'm just reading off my notes that you have, it's composed of 3 phosphate groups and an adenosine unit plus this ribonucleic acid. And it ends up that what happens is you have ADP that in a special location in the cell called a mitochondria, you put that extra phosphate on there. And then this little energy packet goes shooting off to some other location in the cell where we need energy to do work, and it pops that phosphate off, and the excess energy that it's carrying is used to do the cell's work. And so, but then that leaves a phosphate and an ADP, and that ADP and that phosphate can go back to that special location in the cell where you make energy, the mitochondria. There's a lot of them around, but it goes back to one of these mitochondria, and it gets regenerated. So ADP plus a phosphate gets converted into ATP, goes and does work, they break apart, and then they go find their way back and they get regenerated into ATP again. This is how work is done in the cell. It's using this RNA nucleotide with extra phosphates on it. We're done. We're done for today. I know today is a somewhat challenging lecture, so I want you to be sure and ask questions either in person or elsewhere, virtual. And hopefully I've explained it well enough, but I imagine you'll have some questions, so be sure to ask. And I'll do another review again, so that's sort of our normal process. Have a good day.